My name is Hedging, and today I'm going to present the stochastic calculus for financial economics, question 1. So for question 1, we given the stock have a current price of S0, the sigma is 12%, delta is 1%, and we need to, the stock price follow a binomial model with 36 periods, 1 month each, means we need to convert 3 years, and then the R value is 7.4%. So for question 1I, we need to determine the price of stock at 0, which is S0. If the price at 0 of a 3-year 42 strike American call option is this value. So for question 1I, we given the call option value, American call option value is this one, and the care value is 42. So first of all, we insert all of the data, and of course the S0 is unknown first. But for H is 1/12 since we need the data is given in every month, and the U value is following this function, D value is following this function, and the true neutral probability also following this function. So for the stock price, we use the if-else function. If the C18, which is the value before this, the stock price is 0, we have another if-else function. The value above it is 0, will become 0. Else will become this value multiply the D value since it's downwards. Else, we will use this the stock values multiply the up function. So for every single step, we use this function. And then we also given a call option value. So we need to convert a call option function. So for the call option, at the last period, the function is st minus k. So we use the max function, which is aim18 minus the k. But since the value only can be positive value, so we use the max function. If the st is lesser than k, will become 0 for every single value. And then we need to discount it back. So we use another if-else function, but inside got a max function again. So for discounting the value back, if this value is 0 and 50x0 will become 0. Else we use the max function, which is C12 multiply with this, and C13 multiply with this, which is the true probability multiplied with the upward value, and the 1 minus true probability multiplied with the downward value. And then we need to discount back, so we use the exponential power minus R times H. But since it's American option, so we need to compare the discounted value and also the ST minus K for each period. Else, if the value is negative, we make it beyond 0. And we discount it back all the way. Okay, so for now, what we need to do is to find the S0. We could use the goal-seek function by changing the call value become 10.93770181 by changing the cell of S0. So we just need to wait for the Excel to try and error and calculate for the value. After that, we got the value is 45.584121237 for the S0 value. So the first part we have done for question 1, 2, by using the value of S0 in 1, construct a binomial tree with 12 periods, and then we determine the price for a 1 year at the money European put option. At the money means the S0 value is equal to the strike price, and for this case, it's European put option. What's the difference between European and American? The European option is we only can exercise the option at the end of the maturity, but for American call option, we can exercise every time just to ensure the profit. So for the second part, we also insert all the value. And for the last column of the put option, it's not become ST minus K anymore. It's become K minus ST. But since it's also have to be the positive value, so we also use the max function. And the column before it is also using the discounting, but the only difference is we don't need to compare discounted value with the maximum of K minus ST anymore, since it's European option. So we only can exercise at the end of the time. After discounting, we got the put value is 0.96530167. So we have done a second part now. For the third part, by using the S0 in 1, we need to construct a binomial tree with 18 periods, and then we need to find the delta and gamma at time 0. For the 1 year at the money again, European call option. This time is call option. So we need to do the call option also. For the last part is ST minus K, and discounting back, we get this value. For time 0 delta, following this function formula, exponential power minus delta H, Cu minus Cd over Su minus Sd. After insert the function, we got the value is 0.754643051. For time 0 gamma will be a bit complex, which is we need to use this formula. The up node delta minus down node delta divided by Su over Sd. For the up node delta, the formula is exponential power minus delta H Cuu minus Cud over Suu minus Sud. The C value is core and the S value is stock. For the down node is exponential power minus delta H Cud minus Cdd over Sud minus Sdd. And then we insert into the function in Excel. We got the time 0 gamma is 0.0455629795. So after the presentation of question 1, we are going to present question 7 of our CBT. So for question 7 is about the currency exchange. Tamara Mellon, a London-based fashion designer, is expecting to receive this value of yen from a Japanese company as payment, and we are considered about the potential exchange rate fluctuation. So the company decided to hedge the currency risk by purchasing option and exchange the yen for pound at the rate of 0.0055 pound per yen. So this is our K. Given the following information, the X0 is 0.005 pound per yen, the sigma is 0.08, the R for yen is 0.055, and the R for pound is 0.035. So for 7A, I'm required to calculate the cost of hedging using a 12-period binomial using two distinct approaches, which is pound denominated and yen denominated. So for pound denominated, we must assume ourselves is a British, and we are expecting to receive this value 100 million of yen at the end of the exercise time. So what we have to do, we have to sell our pound to get the yen. So for pound denominated, we have to use put option. So for X0, we insert the value 0.005, the K is 0.0055. And since it's pound denominated, so our R for domestic is using pound value, which is 0.035. And the R value for foreign is using yen, which is 0.055. And then the sigma is 0.08. The H is, of course, is monthly, so it's 1 over 12. And the U value is using the formula exponential power R minus RF. The RF is foreign risk-free rate times H plus sigma square root of H. And the D is exponential power R minus RF power, times H minus sigma square root of H. And the P value is a true neutral risk-free rate, which is exponential power R minus RF times H minus D over U minus D. So we got 12 steps, and the amount is 100 million. So first of all, we list down for the 12 months, for the 12 periods binomial tree by using the if-else function. So for the first value, of course, is our x0, 0.005 at the time 0. For period 1, we use the if-else function. If the left cell is blank, we will go into another if-else function. If the left upper cell is blank, we get blank. Else, we will get the left up cell multiply with the D. So we will go downward. Else, we will get the left cell multiply U. So in this case, we got a U value, D value, and then we just drag until the last period. So for pound denominator, we have to do put option. For put option, the last column is maximum of 0 and C4 minus R5. C4 is our care value, which is 0.0055, and R5 is the last column, first value, which is 0.00647 of our exchange rate. Since it only can be the positive value, so we use max function for the whole column. After that, we need to discount it back. We also use the if else function by the right cell multiplying the p, the true neutral probability rate, and the right down cell multiply with the 1 minus p star, and the whole thing we need to exponential power minus r multiply with h. Since in this case our domestic is C5, is pound r value, so we use the r pound value multiply with the h. After that, we discount everything back. We got the put value is 0.000592163. And then for yen denominated, we have to assume ourselves as a Japanese. So to get the yen 100 million, we have to buy. So we have to use the call option to exchange for the exchange rate lah. To exchange for the foreign currency, we have to use the call option. In this case, the x0 is totally different because we need to use the put call duality, which is 1 divided by the x0 above 0.005, we will get 200. K value as well, 1 divided by the K value above 0.0055. And the R domestic now become for yen, and the R for foreign is become pounds. After this value change, our U, D, P, and 1 minus P also will change. So for same, we do the same thing for the exchange rate, just the first value become 200, which is after the put call duality. And the call value, the last column now is not K minus ST anymore, which is become ST minus K. And the K value is already changed. So we discount everything back. We will get the call value is 21.5331974. After we've done everything, for the put denominated, for the pound denominated, the cost of hedging is 100 million multiplied with our put option value. And for the yen denominated call is we need to make some arrangement, which is because previously for exchanging 1 pound, we got 100 million yen, but now the K change, so we have to use the 100 million divided by the K value, and then we only can multiply with the call so that we get balance. And the value is 11843258.57. So we have done our 7A. Now we move to 7B. To calculate the price of an option by conducting a Monte Carlo simulation of 100,000 iterations using Excel. For the task, assume that the Basel framework is applied to the currency exchange rate. So in this case, we have to construct a 100,000 iteration. So we list down until 100,000. And the random variables for 100,000, we use the function RAND. The Z score, since it's the standard normal, so to find the inverse, we use the function norm S inverse of the random variable for each. And the exchange rate, since it's follow Black's goals, so we can use the function. This currently is year 1 for 1 year, so it's x1. X1 is equals to x0 multiply exponential power r minus rf minus 0.5 sigma square times t is equals to 1, so times 1, and plus the sigma square root of 1, square root of t is 1, so square root of 1, and then multiply with the Z score. After we insert into the function, we will get this equation, and the exchange rate will be this. So for the payoff, we can choose to use pound denominated or the yen denominated. For pound denominated, we have to use the put function, which is using the k minus the exchange rate maximum, also the maximum function. After everything, we have to find the expected payoff, which is the average of all the payoff. So for the option price, is just the expected payoff multiplied with the exponential power minus r pound times t minus t, which is 1. Of course, don't forget to multiply with the 100 million. So the value will be auto-generated. Yeah, and that's all. Thank you. Thank you for the looking.